Can you all hear and see me, guys? Can you all hear and see me? Give me a hello. Give me hello if you can hear and see me, guys. Welcome back. It's another calculations masterclass by Pre-Read Shortcast. I hope you are all very well this evening, and I hope you are all ready to smash out some calculations. Today, unfortunately, it is the last of our free lives on YouTube with us today, guys. That means that we're only going to have one last winner of our 1 week free trial of our standard program. Okay, so today is our last session, but we have got lots of questions for you, and all of our questions are going to be from our question bank. So guys, who is excited? Give me a yes, if you are ready to smash out some calculations. You just need to have something to write with, something to write on, get your GPhC approved calculator, and we can actually get smashing on some questions. Okay, fantastic, guys. Amazing. Yes, Amna's going, yes. Loving this energy. Yes, let's go, guys. Let's go. So, fantastic. So, all of these questions today are from our question bank. Of course, we have our beautiful question bank, and our question bank covers absolutely everything within the GPhC assessment framework, okay? You have questions on calculations, clinical, OTC, MEP, all of it's there for you. Over 1,000 questions. It's amazing, right? So, guys, okay, so essentially, how many of you are ready to smash out some calculations today? We have got 6 questions here for you. We've got an hour session. It's not half an hour. It is an hour. So we have extra time. Woohoo! So fantastic. We're getting lots of yeses. Hi, Alexandra. Hi, Princess. Hi, Rani. How are you? Okay, amazing. Loving this energy, guys. Absolutely loving this energy. Okay, guys, as usual, rules will apply. Okay, 3 minutes per question, and then we're going to go through each of these questions. Okay, so these questions, some of them are going to be easier than others. Okay, some of these questions are going to be easier than others. We've got some challenging questions, but we will go through them. Don't panic, don't stress. It'll be perfectly, absolutely a-okay. Okay, so guys, okay, so let's get started on your first question. Your first question is going to be based on pharmacokinetics, and you really need to be hot on your units for this question, guys. Okay, so your time's going to start now, guys. And here is your first question. Okay, guys, that was your time. That was your time, guys. What answers do we have? Okay, Marco, you were straight in there with 150. Okay, amazing, amazing, amazing. Getting lots of 150s. Princess, you say 150. The vow in the house. Yes, 150. Fantastic, fantastic. That is the correct answer, guys. That's the correct answer. You're absolutely smashing this. Okay, you took me seriously when I said we're going to smash these questions. Okay, absolutely fantastic. So the correct answer is going to be 150 milligrams. Absolutely fantastic. So I've been quite cheeky in this question in terms of units, and I did give you that clue before you started this question. Okay, so essentially we have a 12-year-old patient. They weigh 50 kilograms, and essentially they've had a cardiac arrest, and we need to give him dopamine. Okay, we need to give him IV dopamine. I've told you that the steady state concentration is 10 microgram per mil, and the volume of distribution is 0.3 liter per kilogram, and the salt factor and the bioavailability is going to be 1. Okay, so the one awkward thing that I've done here, guys, is going to be units, okay? So we've got a steady state concentration of 10 microgram per milliliter, but in the equation here, essentially our steady state concentration has the units of milligram per liter. So we actually need to convert that, okay? So how we can do that, if it's going to be 10 microgram per mil, that means it's going to be 10,000 micrograms in 1 liter, and therefore converting that back, okay, that's going to be 10 milligram per liter. Sorry, that's meant to say a liter there, okay? That'd be 10 milligram per liter, okay? Fantastic, okay? Then, next thing that we've got to do, we've got to calculate the volume of distribution. We know that the volume of distribution is going to be 0.3 litre per kilogram. Okay, and of course, the units in the equation is just going to be in litres. So, of course, in order to calculate the volume of distribution, it's going to be 0.3 litre, multiply that by 50 kilograms, and that's going to give us an answer of 15 litres. Okay, so then essentially what we have to do is then we just have to calculate the loading dose. So we've got all of our units in the right place. So essentially what we have to do, guys, is that essentially we're just going to do our steady state concentration, which is going to be 10 milligram per liter, as we just calculated. Multiply that by the multiply by the volume of distribution, which is going to be our 15 liters. Divide that by our salt factor and bioavailability, both of which are going to be 1. And then essentially that's going to give you an answer of 150 milligrams. Okay, fantastic. Does that all make sense about this question, guys? Give me a yes. Give me a yes if that makes sense, guys. And you are ready to move on to question number 2 of the evening. Okay, question number 2 is a different type of question within the GPhC assessment framework. All of our questions are up-to-date GPhC-style questions that all have the answers and rationales like this for you in our question bank. Okay, guys. Yes, we're getting some yeses. You are ready to smash out some more calculations, guys. Absolutely fantastic. Let's move on to question number 2 of the evening. And your time starts now. Okay, guys, fantastic. That was your time. That was your time for this question. Fantastic. You guys are smashing it already. We've got lots of answers through already. Marco says 31. Deval says 31. Rani says 31. Amna 31. Princess 31. Fantastic, fantastic, guys. Okay. Rosita in the house, 31. Amazing, amazing. Awesome, awesome, guys. Amazing. Okay, so 31 is the correct answer. Okay, so that's fantastic, guys. Well done, well done. That is the correct answer. So essentially, we have a 27-year-old patient. They have cystic fibrosis, and they currently weigh 79 kilos, and they have Creon 25,000 prescribed to them. Okay, and essentially, I'm telling you that in each capsule, okay, we're going to have 25,000 units of lipase, 18,000 units of amylase, and 1,000 units of protease. And I've told you what the maximum dose of lipase is, and that's going to be 10,000 units per kilogram per day. And essentially, we need to calculate the maximum number of capsules the patient can take daily in order to stay within that maximum lipase limit. So the first thing that we've got to do, guys, is actually calculate what is the absolute maximum lipase that this patient could take in a day. And we can easily solve that by actually calculating the maximum dose. You can do that by, if it's the maximum dose of lipase is 10,000 units per kilogram per day. So therefore, we're going to do 10,000 units, multiply that by our 79 kilos, and that's going to be equal to 790,000 units of lipase. Okay, so we know that each of these capsules are going to contain 25,000 units of lipase, and essentially we need to calculate how many capsules this is going to be for the patient. So if the maximum dose is 790,000 and each capsule contains 25,000, we're actually going to do 790,000, divide that by 25,000, and that's going to give you an answer of 31.6. Okay, we actually need to round down in this question, okay, to 31, okay, because 32 capsules would actually be classified as an overdose for this patient. If we gave 32 capsules, okay, 32 capsules, multiply that by 25,000, in my head, that should actually come up to 800,000 units of lipase, okay, and we know that's going to be 800,000 units of lipase, and that would be an overdose of lipase for this patient, and therefore that is the reason why we have to round down to 31. Okay, fantastic. Does that make sense, guys, about this question? Give me a yes if this makes sense, guys. Give me a yes if this makes sense. Okay, fantastic, fantastic, guys. Are you ready to move on to question number 3 of the evening? If you are ready to move on to question number 3 of the evening, give me a 3, guys. Give me a 3. If you are ready to smash out the next question, you guys are absolutely killing this. It's amazing. Okay, fantastic. Let's move on, guys. Yes, Amna's going. Yes, 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 yes. Amazing, amazing. Lots of freeze, lots of freeze. Fantastic. Here is your next question, guys, and your time starts now. Okay, guys. Okay, that was your time for this question. That was your time. That was your time. So, fantastic. We're getting Marco. You're straight in there again. 240.5. Deval. 240.5. Fantastic. You're in there straight running again. 240.5. Okay. If you put an answer of 240.6, okay, you done your method correctly, okay. What you haven't done is that you haven't given me the answer to the nearest 0.5 mils. Okay, so if you gave me an answer of 240.6, you haven't actually given me your answer to the nearest 0.5 mils. Okay, and if you struggle, that's perfectly fine. We're going to go through this step by step, and it's perfectly a-okay. Honestly, we're all here to learn together. Okay, so we have essentially, let's put the scenario into perspective. We have a 50-year-old patient that weighs 70 kilograms, okay? And they've drank antifreeze. We don't have fomeprazole, so therefore we need to start treatment with oral ethanol, okay? And we're being told that the oral loading dose for ethanol, okay, in the form of wine, beer, or cider, at a concentration of 11% strength, okay, of ethanol is going to have a loading dose of 2.5 ml per kilogram. Okay, and essentially, unfortunately, we don't have any wine, beer, or cider at 11%. We currently only have beer at 8%. Okay, and essentially what we need to do is that we need to calculate how many milliliters of 8% beer will be required to provide this loading dose of ethanol for the patient. So the first thing that we've got to do, guys, is actually we need to calculate this loading dose for the patient. Okay, and essentially how you do it is essentially you can go straight on by doing 2.5 milliliters, multiply that by your 70 kilograms, okay, and that's going to give you 175 mils. Okay, there's two methods actually in which you can solve this. Okay, I'm going to tell you the two methods. Okay, so you can actually solve this now by using your C1V1 C2V2 formula. You can do 11%, multiply that by 175 mils, is going to be equal to 8% times that by your volume 2. You can solve that for volume 2, and that can actually give you your answer straight away of 240.625 mils. Okay, does that make sense about how you can use the C1V1 C2V2 formula in this question? On the slides, I have shown you a slightly different method, but I'm a great believer in teaching more than one method where possible, and trainees can just pick a method which they like and they can stick to it. Okay, does that make sense how you can use the C1V1 C2V2 formula for this question? Yeah, it makes sense. Okay, fantastic. Okay, so oh, sorry, that's a typo. The 2.5 milliliters, multiply that by 70 kilos, will actually give you 175 mils. Okay, so 2.5 milliliters, multiply that by 70 kilos, will give you 175 mils. So we know that essentially we need to give 175 mils of ethanol, 11%, to this patient for their loading dose. Okay, but unfortunately we only supply an 8% volume of ethanol, so we can actually use the C1V1 C2V2 formula to solve this. Alternatively, if you're not a fan of the C1V1 C2V2 formula, you can actually essentially, well, how much ethanol in grams does this patient actually get? So if we know that the patient actually needs 175 mils of 11% ethanol, okay, you can actually find out how much grams is actually going to be. So essentially, you can actually find this out if you do 11 grams over 100 mils, because of course your percentage rate and volume is always going to be expressed in grams over 100 mils. Okay, it's going to be equal to X over 175 mils, and that's going to equal to 19.25 grams. So therefore, the patient would actually have 19.25 grams of ethanol. Okay, that's how much they need in grams of the ethanol. And then this point, that's when you can actually use the 8% beer. So if we know that the patient needs 19.25 grams of ethanol, okay, and we're going to have an 8% beer, you can use a cross multiplication method where you have your 19.25 grams over X is going to be equal to 8 grams over 100 mils, and you can solve that, and that will give you an answer of 240.625 milliliters. And to round to the nearest 0.5 mil, that's going to give you an answer of 240.5 mils. Does that make sense about this question, guys? Okay. Just let me know if you're still stuck on anything, guys, at all. Okay. Just let me know if you're still stuck on anything. Okay. So essentially, if you struggle in terms of your rounding to the nearest 0.5 or rounding to the nearest 0.05, there is a YouTube video that you can watch. I think it was only about done like a week ago or 2 weeks ago. I think it's about 2 weeks ago maybe, of talking about math skills, and I actually covered that topic in that video. So you can check out that video, and then we covered that, essentially that particular rounding method there for you, just to help you with your GPhC exam. Okay, fantastic. We're getting lots of yeses through. All making sense. All making sense. Fantastic. Fantastic. Okay, so essentially, let's move on to our next question, guys. Question number 4 of the evening. Here is question number 4 of the evening. And your time starts now. Okay, guys, we're getting quite a few different answers for this question. Did you find this question quite challenging? We're getting some 2.62. We're getting some 0.03. Okay, so getting the general consensus of 2.62, 0.03. We've got another 0.03. Okay, okie dokies. Okay. Okay, let's go through this question step by step. Okay, so essentially we have a 70-year-old male in a cardiology ward, okay, who weighs 70 kilograms, okay, and they're going to be administered digoxin, okay, for rapid digitalization, okay, at a dosage of 2 nanomoles per kilogram per minute, okay. So the molecular weight of digoxin is 781.01 gram per mole, and I've told you that that digoxin is available as a 30 milligram per 5 ml injection. Okay, and essentially you need to calculate the volume in milliliters of digoxin that needs to be administered over that 24-hour period, and you have to give your answer to the nearest 0.01 mils. So yes, I have been really sneaky, okay? So how many of you read this as 2 millimoles per kilogram per minute? Okay, some of you did. Okay, that's not a problem, okay? So we get an answer of 26.24, 26.24, fantastic. If you got an answer of 26.24, that is the correct answer. That's absolutely fantastic. Well done. So let's go through this, okay? So essentially we need to calculate how much digoxin gets administered to the patient in milliliters over that 24-hour period. Okay, so essentially the first thing that we need to do is that we actually need to calculate, well, how many nanomoles of digoxin does this patient get over that 24-hour period? So it's going to be 2 nanomoles per kilogram per minute. Okay, how we calculate it over a 24-hour period is that we're going to do our 2 nanomoles, multiply that by 70 kilos. Okay, so it's meant to say 2 nanomoles, multiply that by 70 kilograms, multiply it by our 60 minutes, multiply it by 24 hours, and that's going to give us 201,600 nanomoles. Okay, so what we do, we're going to convert this to millimoles. Okay, we're going to convert this to millimoles. That's going to be 201,600 nanomoles. It's going to equal to 201.6 micromoles, and therefore convert that to 0.2016 millimoles. And the reason why I converted my answer to millimoles is essentially, the reason why I've done that is because we wanted to, if you get your answer in millimoles and you multiply by the relative atomic mass, you're going to get an answer in milligrams. Okay, does that make sense, guys? Okay, does that make sense so far, guys? So we're going to have 2,000, so we're going to have, sorry, give me 1 second, my laptop is just about to die, just 1 second, guys. Fantastic, can you all hear and see me? I hope you can. Fantastic, fantastic. Apologies, my laptop was about to die and I was trying to explain the question and plug the laptop in, and I was thinking, nope, I've got to plug the laptop in. Okay, so essentially the reason why I converted my answer to millimoles here, okay, is because if you have essentially millimoles, multiply that by the relative atomic mass, you get a mass, but in milligrams. If you're going to do moles, multiply that by the relative atomic mass, you're going to end up having an answer coming out in grams. Okay, does that make sense, guys? And the reason why I wanted to actually have my answer in milligrams, it was essentially to make my life easier for the digoxin, because it's going to be available as a 30 milligram per 5 ml injection. So therefore I'm keeping all of my units the same, and it's going to essentially just make it to actually reduce the risk of errors a lot better. Okay, so as a result, we're going to get our millimoles, we're going to multiply by the relative atomic mass, and that's actually going to equal to 157.45161 milligrams. Okay, so if we're going to get our answer in milligrams here, we want to calculate what volume that's going to be. Okay, so if the patient's actually going to end up getting 157.45161 milligrams over that 24-hour period, we want to find out how many milliliters that's going to be, because the digoxin is available as a 30 milligram over 5 ml concentrated solution. So what we can do, we can cross multiply. So essentially we can get our 30 milligrams over 5 mils is going to be equal to 157.45161 milligrams over X. And that's going to give you an answer of 26.241935 milliliters. Round it to the nearest 0.01 mils, and that's going to give you an answer of 26.24 mils. Okay, does that make sense, guys? Does that all make sense, guys? If you're stuck on anything, please do just let me know. Okay, it's all making sense. Fantastic. Okay, so there was a question about essentially why am I getting my answer in milligrams? So essentially, if you have your answer in millimoles, if you have something in millimoles and you want to convert from millimoles to a mass, if you multiply by the relative atomic mass, okay, if you have your millimoles multiply by the relative atomic mass, you're going to get an answer in milligrams. If you're going to have moles and you multiply by the relative atomic mass, your answer is going to be in grams. So essentially, if you're converting from masses, it'll be millimole to milligrams, and then moles to grams. Does that make sense about how you can essentially we can clear that up, guys? Okay, I'm getting lots of yeses, so it's starting to make sense. Fantastic, fantastic, fantastic. It's making sense. Okay. So, fantastic, guys. Okay, right. Are you ready for your next question, guys? This question is actually going to be on displacement volume, but it's actually going to be quite a savage displacement volume question. So, if you are ready, give me a question number 5. Give me a 5, guys, if you are ready for number 5 of the evening. Okay. So hang on, you're saying okay, we're getting some 5s, we're getting some 5s, we're getting some 5s. Okay, fantastic, fantastic. Okay, let's go on. Okay, here is your next question. Okay, guys, fantastic, fantastic. Okay, so we've got some answers for already. Okay, how many of you struggled a little bit on this question? So it's not like your classic displacement volume question. I've added a bit of a twist in here. So we've got some answers for already, guys. That's fantastic. So we're getting 139, 139, 139. Fantastic, fantastic. Okay. That's correct, guys. Okay, that's amazing. 139 milligrams is the correct answer. That's absolutely awesome. Okay, so essentially, we have a 4-year-old child and they need Cephalexin, okay, for the treatment of otitis media, and we know this child's going to be weighing 18 kilograms. In order to prepare the suspension, we need to add 66 mils of water to 100 mils. We need to add 66 mils of water to produce a 100 ml suspension, okay? And the concentration of this suspension is going to be 125 milligram per 5 ml oral suspension. That's the concentration of the solution. Okay, so we just imagine in your pharmacy, you know, you're going to have those pre-made bottles of those antibiotics. It's going to be the antibiotic bottle in there, and you're going to have basically that powder. You pour in 66 mils of that water, and then you're going to have 100 mils as your total volume, and the concentration of the suspension is going to be 125 milligrams per 5 ml. Okay, but what happens is that your technician accidentally messes this up for you, and what they do is that they accidentally add 56 mils of water instead, rather than the 66 mils that they should have done. And essentially, as a result, if you add in the wrong amount of water, you're going to end up, if you add in less water than what you should have done, you're going to end up having less volume, okay, than what you should have, and as a result, the solution is going to be more concentrated. So essentially what we need to do is that we need to calculate how much Cephalexin in milligrams is actually going to be in that 5 ml bottle, in that 5 ml dose, okay, due to that dispensing error. Okay, so what we actually have to do, okay, is that essentially we have to calculate the total displacement volume under normal circumstances. And there's logic in my madness here, and hopefully it will all make sense soon. Okay, so what we do, okay, if you imagine this is going to be kind of like our bottle of antibiotic, okay, so imagine that we've got powder essentially come out at the bottom of this antibiotic bottle, okay, because they're going to be pre-made packets, okay. So we're going to add 66 mils of water, shake it about, and then essentially our final volume is going to end up being 100 mils. So therefore that tells us that this whole amount of powder in this bottle is actually going to displace 34 milliliters. That's basically what it's telling us, that the whole amount of antibiotic powder in the bottle actually displaces 34 milliliters. Okay, then what we need to do next is that actually we know that if the whole amount of antibiotic powder displaces 34 mils, we actually need to find out how many milligrams is actually present throughout the whole bottle, okay? Because we have to remember that these bottles are pre-made, and so they're designed to have that set amount of antibiotic in, okay, for you to measure the correct amount of water to give you the correct volume and therefore the correct concentration. So if the concentration of the solution, okay, when it's made up correctly, is going to be 125 milligram in 5 mils, okay, the final volume is meant to be 100 milliliters. So therefore that tells us for in this whole antibiotic bottle, we're going to end up having 2,500 milligrams of antibiotic powder. Okay, does that make sense so far, guys? Give me a yes if that makes sense so far. And the reason why these two steps are actually really important is because the total displacement volume never changes. Even in a dispensing error, your total displacement volume will never ever change. And the amount of antibiotic powder made in this bottle is never going to change. Okay, so then now what we have to do is that we need to calculate what volume do we end up getting because of a dispensing error. So your technician accidentally adds 56 mils rather than the original 66 mils. And we know that the total displacement volume is going to be 34 mils. So therefore, what actually happens is we're adding our 56 mils. We know that that total amount of antibiotic powder displaces 34 mils. So therefore, that 34 mils plus that 56 mils gives us 90 mils in total. Okay, because this little formula of the total volume is going to be equal to our displacement volume plus the volume of water added. Okay, so essentially what we're getting as a result of the dispensing error is that we're going to have 2,500 milligrams of antibiotic powder, but it's actually going to be in 90 mils rather than the 100 mils. Okay, so then we actually have to find out, okay, we've got this messed up concentration now. Okay, the solution is now more concentrated than what it should have been. So we actually need to find out, well, how much cephalexin is going to be present in this 5 mils now because of this messed up concentration. So if we're going to have 2,500 milligrams in 90 mils, if we're going to do equals to x over 5 mils, so we can do that cross multiplication, that's going to give us an answer of 138.888 recurring, and therefore that's going to give us 139 milligrams to the nearest whole number. Does that make sense, guys, about this question? Okay. Is anyone still stuck on this question at all? Or are we all good in the hood? Okay, fantastic. Yes, we're getting lots of yeses through. Lots of yeses, lots of yeses. Fantastic, fantastic. Okay, awesome, awesome. Lots of yeses. Okay, amazing, amazing. Okay, guys, are you ready for the last question of the evening? And then, of course, it's going to be our raffle time. Okay, it's going to be our last winner of our 1 week free trial. Okay. Oh, sorry, someone's just asked me, could I go over step 3? Yes, of course, I can just go over step 3. Okay, so what actually is happening in this scenario is that essentially, imagine this is going to be our bottle of antibiotic. Okay, imagine this is going to be a bottle of antibiotic. The powder, we know that there's going to be 2,500 milligrams of antibiotic powder in the bottle. These bottles are pre-made. This doesn't change. We've already calculated what the total displacement volume is going to be in step 1, and that doesn't change either. Okay, and a vital formula for you to remember in any displacement volume question is this. Total volume is going to be equal to your displacement volume plus volume of water added. Okay, it could also be like sodium chloride for diluent. So basically, if the volume of diluent or water to be added. Okay, so essentially, what was meant to happen is that we're meant to give, basically have our antibiotic powder. We're meant to give 66 mils, we're meant to put 66 milliliters of water into this bottle. Okay, and as a result, that's ideally meant to give us 100 mils of a 125 milligram in 5 mil suspension. That's what's meant to happen. But what happens is that we're actually giving, your technician has actually done 56 mils instead. Okay, so if you're adding 56 mils, and we know that the displacement volume is always going to stay the same because 2,500 milligrams of cephalexin displaces 34 mils, you do your 56 mils plus your 34 mils, and as a result, you only get 90 mils as a total volume rather than the 100 than what you should have got. Okay, so therefore, what actually happens is that you've got, if you add less water, you're going to have a smaller, you're going to have your final volume is going to be less than what it should be, and you're going to have a more concentrated solution. So you're actually going to end up having 2,500 milligrams in 90 mils, but it actually should have been 2,500 milligrams in 100 mils. Does that make sense about step 3 now? Okay, just let me know if that makes sense, and then we can move on to the last question of the evening, and then it will be raffle time, guys. Okay, fantastic. Okie dokies. Okay, fantastic. Let's move on to the last question of the evening. Last question of the evening, guys, and then it will be a raffle. It will be a raffle. Here's a nice question here for you, and your time starts now. Okay, guys, fantastic, fantastic. We're getting some answers already. This is a nice question to end the evening with. We're getting Marco, you're straight in there again at 13.6, followed by Amnon and Rani. Amazing, amazing. Lots of 13.6s. Fantastic. 13.6, 13.6. Awesome, guys. Fantastic. Okay, so mixing concentrations is a part of the GPhC assessment framework, of course. So essentially, this is a very common question that could potentially come up in the exam. Okay, and often trainees always get a bit flustered about essentially solving this question, but essentially it is a lot easier than what you actually think it is when you first look at it. Okay, so easiest thing to do with this question, essentially to break it down. Okay, imagine it's a cocktail. Okay, imagine we are making a cocktail with glucose. Okay, and essentially we're going to mix all of these things together, and we actually want to find out what is the percentage strength of our cocktail. Okay, so easiest thing to do is actually to find out how much glucose is going to be present in each of the solutions. So first of all, we're going to tackle 10%. We have a 10% glucose solution and we have 350 mils of this. Okay, so if we have 350 mils of glucose and it's a 10% solution, we want to find out how much glucose is going to be present in each of those basically in this part of the solution. Okay, so in terms of you do 10 grams, divide it by 100, because of course percentage strength is going to be expressed in grams in 100 mil. And then you're going to multiply by 350 mils, and that's going to equal to 35 grams. Okay, 600, and you're going to do the same thing for your second part of the solution, where you're going to have 675 mils of this 20% glucose solution. So to tackle how much glucose is going to be present in this solution, you're going to do 20 grams over 100 mils. Multiply that by 675, that's going to give you 135 grams of glucose. And of course, the last part of the cocktail is going to be 225 mils of sterile water. Okay, there's then essentially kind of like in terms of how much glucose is going to be present in here, is going to be absolutely nil point. Okay, absolutely no glucose in here because we're just adding water. Okay, so therefore essentially this is how we've broken down essentially our little cocktail. Okay, so essentially what you need to do is that you need to calculate your total volumes from all the three different solutions, our three parts of our cocktail. Okay, so that's going to be our 350 mils from the 10% solution, 675 mils from the 20% solution, and our 225 mils from the sterile water. That's going to tell us that we're going to have a total of 1,250 mils. That's going to be the total volume. We then want to calculate the total amount of glucose. So that's going to be our 35 grams from our 10% and our 135 grams from our 20%, and that's going to give us 170 grams. So therefore, within this whole cocktail, we're going to have 170 grams of glucose in a total volume of 1,250 mils. And we want to convert this to a percentage strength. Okay, of course, our percentage strength is actually going to be expressed in grams per 100 mil. So if you can do a cross multiplication, so you can do 170 grams over 1,250 mils is going to be equal to X over 100 mils. That's going to give you an answer of 13.6. Therefore, it's going to be 13.6 grams in 100 mils. Therefore, your answer is going to be 13.6. Does that make sense, guys? Okay, give me a yes if that makes sense. It's quite a nice question to end the session on, really, guys. Okay, fantastic. It's all making sense so far. Amazing, amazing. So, guys, it is raffle time. Okay, today is the last YouTube session. Okay, and we have one of you guys will be the lucky winner. One of you guys will be the lucky winner of a 1 week free trial of our standard program. So our standard program is a really comprehensive program where you have access to our clinical calculations, OTC, MEP, there's mock papers, the question bank, it's all there for you guys. Okay, so guys, if you are interested in winning this nice freebie, give me a me if you are interested in winning this freebie, guys. If you are interested in winning this freebie, give me a me, guys. Yes, we're getting lots of yeses. Give me a yes or a me. Give me a yes or a me. Give me a yes or a me, guys. Amazing, amazing, amazing. Okay. All right then. The chat is going crazy. Awesome, awesome. Okay, I'm going to cover my eyes and I'm going to select someone at random. I'm going to select someone at random, guys. Okay, let me just get my scroller up, down, up, down, up, down, up, down. Okay, and I'm going to... Oh, hang on. I've lost my scroller. I'll do it again. Okay, put me in the chat. Me in the chat. Okay, so my lucky winner is... Marco Andini. Fantastic, you've won. Marco, you have won the 1 week free trial. You have won the 1 week free trial of our standard program. In order, essentially, to get access to this, Marco, you need to email uma@prereadshortcuts.com. I'm just typing that there for you. Just give me 1 second. Okay, so Marco, you actually need to email uma@prereadshortcuts.com to say that you were the lucky winner of our 1 week free trial of our standard program. So congratulations, Marco. Congratulations. So guys, please do check out our website. We have lots of free content out there for you. We have lots of free content on YouTube. Okay, we have over 140 hours of recorded content and we have over 40 live sessions. Okay, essentially in our courses. You get exclusive access to our Telegram group. Okay, we have lots of resources out there for you, summary sheets, mind maps. Okay, we give you a lot of motivational support as well, guys. And essentially we have excellent Trustpilot reviews as well. So please do check out our courses if you're interested in enrolling in our courses. If you are interested, there is a WhatsApp contact details. It's actually in the link. It's in the description for this YouTube link, guys. Okay, so thank you guys very much. I hope you enjoyed this session. I really hope you've enjoyed it, and I hope it gives you a nice good taster essentially of some of the questions in the question bank. Okay, so I hope you enjoyed that, guys. Okay, so congratulations, Marco, once again for being the winner of that 1 week free trial of our standard program. So thank you, guys. I hope you had a nice time. I hope you learnt loads. Okay, so you will smash this. You will smash your exam. You'll smash it like there's no tomorrow. Okay, you will boss the exam and you will all be pharmacists in August. Okay, so you're very welcome, guys. You're very welcome. Okay, so that's the end of the session. Thank you ever so much for joining, guys. You guys are fantastic as always. Okay, it's been a pleasure doing these lives with you. Okay, so that's all from us, guys, at Pre-Read Shortcuts. So we'll see you guys later. Bye.